We're incredibly excited to share with you the next chapter in our Radeon journey. We began with some ambitious goals with RDNA 4, starting with an architecture that enables more players to access enthusiast-level gaming experiences. We focused on where gaming is going and built a significantly improved engine for ray tracing and machine learning technologies to meet the needs of games over the next several years. And finally, we were laser-focused in every product decision to ensure that we deliver the best performance and capabilities that gamers want, while ensuring that we're accelerating our performance per dollar leadership.
It's great to be here today to talk to you all about RDNA 4. There's a lot of exciting details to get through, so let's get straight into it. At its core, the vision for RDNA has remained constant since we started in 2019. We always target the best possible performance that we can engineer for the workloads that will be important to gamers in the life of the architecture. But behind that simple statement lies so much complexity. And as our architects sit down at the start of every new project, we have to navigate through all that we've learned and all that we see coming years into the future to drive our innovation and the areas of the architecture that we will focus on. From the infinity cache, high frequency and ray tracing that we drove in RDNA 2, to the advanced chiplet construction, matrix acceleration and physical design of RDNA 3, we aim to bring the very best of AMD's experience in computation, graphics and advanced construction techniques to bear on the problem of engineering the best products for our gaming customers. Now, with RDNA 4, we are bringing the results of years of research and development to fruition, with the most powerful architecture we've ever designed for gaming graphics. We've targeted every step in the flow of rendering, from the front end, with an enhanced command processor to more quickly handle the commands from the application, through the core, where our updated compute units increase the efficiency of shading and double the performance of ray tracing and deliver even larger improvements in ML, to the memory interface, where we improved our efficiency and compression. Our aim was to make your games run faster and smoother than ever before. Going beyond this, we made sure to also elevate other aspects of the visual experience for our users, with updates to our AMD Radeon display and media engines. The streaming community has asked us for encoding quality improvements for popular services like Twitch, YouTube, and Discord, and RDNA 4 delivers major improvements across H.264, H.265, and AV1. Beyond these broad performance improvements, we also focused heavily on enhancing our ray tracing architecture. We attacked this problem at all levels, not only making RDNA 4 able to trace more rays more quickly, but also creating hardware that operates more intelligently to reduce the overall work. Of the many advanced RT features introduced in RDNA 4, I will call out one key area here that drives the efficiency of ray traversal, which is the representation of the world geometry. The data structure that contains this geometry is called the bounding volume hierarchy, or BVH. In RDNA 4, we've taken an innovative approach to this with a new method for organizing that data that we call oriented bounding boxes. And we also developed better compression for the data itself. And these changes deliver much more efficient ray traversal through the geometry, and with a lower memory cost, making better use of capacity and bandwidth. Within the ray accelerator, we've added a second intersection engine, which doubles the performance for both ray box and ray triangle testing. And based on our analysis of ray tracing workloads, we also created a dedicated ray transform block, which increases the performance of the hardware as rays are traversed into the lower levels of the BVH. With our updated ray accelerators, you will see a transformational change in the efficiency of ray tracing, making great performance available to more gamers at compelling price points and delivering twice the ray tracing performance of RDNA 3 per compute unit, enabling smooth gaming experiences even with complex ray tracing effects. Now, whether an AI model requires high precision with 16-bit floating point, or ultra-high performance with lower precision such as 8-bit or even 4-bit, by adding more dedicated math pipelines and support for techniques such as structured sparsity, we have increased the peak performance per compute unit by as much as 8x compared to RDNA 3. The performance is great, but what can RDNA 4 really do? 20 years ago, we released a demonstration that showed the capabilities of our newest Radeon graphics when using Microsoft's DirectX 9 graphics API. This demo was called the Toy Shop, and I hope that back then it helped to open people's eyes to the kind of graphics that were now possible with advanced programmable shading. Now, as we enter a new era of path-traced visuals combined with ML, we wanted to call back to this a little bit. So I would like to present the latest work of our graphics research teams, being shown here for the first time in a new demonstration for RDNA 4, built with Unreal Engine 5 and enhanced with our latest techniques for neural radiance caching, supersampling, and denoising. And so, I give you our new toy shop.
AMD RDNA 4 owners will get access to a new version, FSR 4, featuring AMD machine learning-powered upscaling specifically developed for RDNA 4 architecture. We are delivering near-native image quality at 4 times lower resolutions. We have improved ghosting, anti-aliasing, particles, fabrics, transparency effects, more effects. The result is much improved near-native image stability with greater performance. In addition to these improvements, FSR 4 works seamlessly with our frame generation and latency reduction anti-lag technology. Everything we discussed is designed with gamers in mind. At the same time, we worked very closely with game developer community. Now we are taking it to the next level with an upgradable and flexible API that empowers developers to seamlessly integrate and deploy future FSR technologies. FSR 4 can be enabled on all participating FSR 3.1 titles. This allows us to deliver FSR 4 on more titles sooner. This means FSR 4 is ready for the future of neural rendering with the same upgradable API. FSR 4 upscaling is end-to-end AI solution developed on AMD consumer platforms with Ryzen processor and Radeon graphics. We trained our model using the latest AMD EPYC and Instinct accelerators and optimize it for the new FP8 ML acceleration in RDNA 4. Our new technology leverages a proprietary hybrid model resulting from extensive research across different types and combinations of neural networks and unique training techniques.
Today, I'm so excited to introduce the Radeon RX 9000 series graphics cards, combining our next generation architecture along with the latest gaming technologies. With a significant performance increase over our prior generation, the Radeon RX 9000 series was built to deliver everything you need for 4K gaming at a 1440p price point. I'm thrilled to announce the Radeon RX 9070, the world's best $549 graphics card. The 9070 is a great option for getting immersed in the latest titles. With 56 RDNA 4 compute units, 16 gigabytes of memory, 2.5 gigahertz boost clock, and over 1,100 AI tops, all in an incredibly efficient 220 watt power envelope, starting at $549. Generationally, at 4K resolutions, the 9070 is able to deliver on average 21% faster performance in over 30 of the most popular games, including both raster and ray trace titles. Games like Cyberpunk and Dragon Age: The Veilguard are great examples where the 9070 is able to outperform the 7900 GRE by 25% or more. In ray tracing, those differences can be even greater, well over 30% in many cases. If you have a 1440p display, the uplift is similar at 20%. And all of this is with no special software enabled, just pure 1440p performance. Now, looking at one of those future titles, our friends at Pearl Abyss are hard at work on their new game Crimson Desert. And we're really excited about this open world action adventure featuring incredible graphics, ray-traced visuals, and FSR 4. Crimson Desert is expecting to launch this year and looks incredible on the latest AMD gaming hardware. Let's check in with Pearl Abyss on their progress.
저희 펄어비스에서는 AMD와의 협업을 통해 액션 어드벤처 게임인 붉은 사막의 방대한 오픈월드를 비주얼적으로 타협하지 않고 표현할 수 있었습니다. AMD 라데온 GPU의 최첨단 기술은 붉은 사막의 그래픽 수준을 확장하는 데 큰 도움이 되었습니다. 라데온에 향상된 RDNA4 아키텍처에서는 다이나믹한 날씨 시스템, 캐릭터의 의상과 지형의 디테일한 표현을 위해 제작된 복잡한 쉐이더가 여유롭게 구동됩니다. 또한 라데온 9070XT의 업그레이드된 레이트레이싱 성능 덕분에 붉은 사막에서는 기본적으로 모든 반사와 광원들이 레이트레이싱을 통해 표현되며 교차되는 검들 사이에서 튀는 불똥과 풀숲의 반딧불이조차 모두 레이트레이싱된 그림자를 드리웁니다. 여기에 FSR4의 혁신적인 업스케일링 기술이 더해지면 오픈월드 환경에서의 대규모 전투나 복잡한 도시에서도 4K 해상도와 디테일을 유지하면서 매끄러운 프레임 레이트를 달성할 수 있습니다. 붉은 사막의 자체 엔진에 이러한 기술들을 통합하기 위해 저희는 AMD와 함께 작업해왔으며 확장성 있는 구조 덕분에 매우 수월한 작업이었습니다. AMD와의 파트너십, 그리고 라이젠, 라데온, FSR4의 시너지 덕분에 저희는 놀라운 품질의 비주얼을 극도로 최적화된 상태로 선보일 수 있도록 노력하고 있으며 유저들이 붉은 사막의 아름다운 월드를 경험하기를 기대하고 있습니다.
I'm happy to say both the 9070 XT and 9070 will be available for sale starting March 6th. And in the second quarter of this year, we'll broaden the family even further with the RX 9060 products, which we'll tell you more about later. From all of us, thank you for joining us today, and thank you for being a part of the AMD gaming community.